Lesson 6.9, Factoring Completely. When we apply the techniques for factoring, we have to determine if we have factored completely. Sometimes we think we're done, but then we find that there are other things that could be factored out. Sometimes we can apply one technique. Sometimes we have to apply two or more. And in order to determine if we have factored completely, it is helpful to have an idea of what to look for and the steps to take. And flowchart is a great way to arrange this information. First, we look to see if we have a binomial, a trinomial, or a general polynomial, which will be 4 terms or more. If we have a binomial, we factor out any common terms. From there, we check to see, is this a difference of squares? If not, then there's nothing more we can do. We're finished. If it is a difference of squares, we factor the difference of squares using our difference of squares format. Then, we ensure that it has been factored completely by reviewing the above steps. If we have a trinomial, we factor out any common terms. By common terms, what I'm referring to is the GCF. Then, we check to see if it is a perfect square trinomial. If it's not, we factor using a factor and sum table, or big giant X, or a combination of the two to convert the factoring by grouping. And then we check that it has been factored completely by reviewing the above steps. If it is a perfect square trinomial, we use our method of factoring for perfect square trinomials. Finally, if we have a general polynomial, 4 terms or more, we factor out any common terms. Then we factor by grouping if possible, and then we check to make sure it's been factored completely by reviewing the above steps. Factoring completely. So first we have this polynomial, 6x to the third plus 4x squared minus 54x minus 18. Oops, sorry about that. So what I'm going to do is I'm going to look, okay, I have 4 terms, so I need to factor by grouping, but first I'm going to check, is there anything that I can factor out of all of these? And they're all even, so I can factor out a 2. So I'll be left with 3x to the third plus 2x squared minus 27x minus 9. Next, I check to see my factoring by grouping, if that's possible. 3x and 2x squared both have an x squared in common, so I'm left with 3x plus 2. 27 and 9, negative and negative, have a negative 3 in common, and I'm left with 3x plus 3. And those don't match, which means I couldn't factor by grouping. Let me just double check. Since I came to a dead end here, I'm going to try to see what happens if I don't factor out the GCF of the 2. And I factor it out up here, and I get a 3x plus 2, and then 54 and 18 will both divide by negative 9, and I get 6x plus 2. Huh. I guess this was all we could do. Let's try another example. X to the fourth minus 16. Now, anytime you have an even exponent, that equals a perfect square. And to take the square root, you divide the exponent by 2. Okay, so x to the fourth is a perfect square. This is a binomial. there are no GCS, but it is a difference of squares, so I have x squared plus 4 and x squared minus 4. Now I have to check to see if I have factored completely. I have a perfect square and a perfect square, but there's a plus here, so that's not a difference of squares. But here I have x squared minus 4. That's another difference of squares. So I have to factor again. So I have x plus 2, x minus 2. Now I have factored completely. Oh, I wrote where I needed to be. Just go ahead and get that out of the way. Sorry about that. Okay, 30x squared minus 8x minus 64. All of these things will divide by 2. And I have 15x squared minus 4x minus 32. 15x squared minus a negative 32, I can either use a factor sum table, or I can use the big giant X to switch it to grouping. I'm going to use the big giant X to switch it to grouping. So I'm going to do 15 times negative 32, and I know that's going to be a really large number. Oh, it's not that bad, negative 480. And then I'm going to factor my 480. Now, if you want to take up less space, you can do factor trees sideways. And then 15 is 3 times 5. Now I'm going to need two numbers that when I multiply them, they will give me negative 480, and when I add them, they will give me negative 8. So I have 2, 2, 2, 2, 2, 3, and 5. So 2, 4, 8, 16, 32, and 15. 32 and 15 have a difference of 17, so that doesn't work. 10 and 2, 4, 8, 16, and 3, that's not going to be a difference of 8. I could do 20 and 12. So here I've got 5 and 2 and 2, that gives me 20, and then 3 and 2 and 2, oh, and 24. That's not a difference of 8. I could do 15, 30, and 2, 4, 8, 16. 30 and 16 will have a difference of 14. Let me think for a second. Getting close. 5, 10, 20, 40. Okay, well, I realized my mistake. This should have been 4, not an 8, and that gives me 20 and 24, and I want this to be negative. That was much easier. So I'm going to take my 2, that doesn't go away, minus 24x plus 20x minus 32. 15 and 24 have a 3 in common and an x. So 3x, and that leaves me with 5x minus 8. And 20 and 32 have a 4 in common. So I take out a 4, and I'm left with 5x minus 8. So I have 2 times 3x plus 4 times 5x minus 8. Now, when this is happening where I couldn't find the combination, that's because I had written down the number wrong. So if you can't find the combination, always double check yourself. Okay, here's an extreme example of factoring. Now, this is a perfect square because it's even. So I'm going to take 256 and divide it by 2, and that's 128. So I'll have plus 1 minus 1. And 1 is also a perfect square, so I have another difference of squares. So I take 128 and I divide it by 2. So I get x to the 64 plus 1, x to the 64 minus 1. And I have another difference of squares, so I have to keep going. All these plus 1s don't factor anymore. So I divide 64 by 2 and I get 32. And that gives me another difference of squares. Okay, half of 32 is 16. And that gives me another perfect square. Half of 16 is 8. I have another perfect square. Now I can keep doing this or I can take my shortcut. When you have an extreme example like this, okay, I have x to the 256 minus 1. That's a difference of squares. I take half, and I keep taking half until I can't take half again, because as you can see, I'm going half each time. Half, half, half. So 32, 16, 8, 4, 2, and then 1. And then finally, I am factored completely.